Hi everyone. Welcome to our channel. This video is continuing from the previous video. If you haven't watched the previous video, we encourage you to do so. The link is in the description below. The title of this video is Don't Believe Everything Your Brain Thinks. With no further ado, let's dive in.
When the brain perceives inputs from external arousals or the internal signals, during the processing step, the brain will interpret the situations based on the present emotional states, the context of the situations, past experiences, expectations, memories, and analysis. Or if that situation requires immediate reflex, the response will be immediate and will not pass through the interpretation steps. Let's recall the first example in the previous video. Tony and Annie both see the same dog barking. Tony's brain interprets that the dog wants to play with him and he's happy to play with the dog. On the other hand, Annie's brain interprets that the dog is going to bite her. She thus got scared and runs away as fast as she can. The exact same input, perceived by two different people, yield different outputs. How is it so? This is because the brains of the two people interpret the stimuli differently. Whose interpretation is correct then? Is the dog going to play with them or bite them? According to American Kennel Club or ACK.org website, a dog barks at people for various reasons, including to show the excitement or even worries, frustration or uncomfortable feelings due to another person's presence. Therefore, either one could be correct. Let me explain the basic concept of how the brain works in the processing step, and then I'll narrow it down to our Tony and Annie example. Now let's take a look at general concepts for processing steps.
When the brain perceives the inputs, it will process the inputs to produce the respective outputs. For the ease of explanation, I would say that during the processing steps, the brain will categorize the inputs into 5 types, which will be processed in 5 different neural pathways in the brain. First, the reflex inputs. Second, habit/routine inputs. Third, emotion inputs. Fourth, positive inputs. And fifth, negative inputs. We're looking at each pathway briefly. This is critically useful as we can exploit the facts that we can redirect the brain to the pathways that can create the outputs that we want. Haha, this is the basic for almost all the brain hacks I will show you later on in the future videos. Hope you stay tuned. This channel will bring you to success in any area you want with ease and with no costs.
First, let's look at reflex input pathway. When any of the 5 senses, namely see, hear, smell, taste, touch, perceives inputs that requires immediate responses, such as when your hand touches a pot of boiling water, the brain will send signals from the inputs through the reflex pathway without going through conscious thoughts to withdraw your hand instantly from the pot. This is how the brain works in the reflex pathway. The sensory receptors detect a specific stimulus, for example, pain, or stretch, etc., and converts it into an electrical signal to be sent to interneurons in central nervous system, or CNS in the spinal cord, or the brainstem. This is where the decision is made in a very rapid, automatic way. Once the decision is made at the CNS, then motor neurons carry out the commands to respective muscles or glands to execute the response to that input in milliseconds. In this case, to withdraw the hand instantly from the hot water.
Second, Routine/habit input. Routine tasks/habits are, for example, driving the same routes, brushing your teeth, tying shoelaces, making daily coffee in the morning, typing the computer keyboard, or even the internal stimuli like stress can trigger habits like smoking, binge eating, and heavy drinking. The key point in this pathway is the repetition of the tasks, which have become habits or routine. Another useful point to know is that this pathway doesn't pass conscious thought, or in other words, it doesn't pass the thinking, and it doesn't pass emotional processing. This saves the brain energy, and it makes the speed of executing the tasks to be fast. We get performance with no pain from the emotions involved. I will show you how to exploit this pathway a lot in the future videos. When the inputs, like your fingers, touch the keyboard, thalamus, which is the relay center in the brain, will direct the signal to basal ganglia to carry out the routine or habitual tasks. Then the basal ganglia, which has stored the motor patterns, will send signals to motor cortex to move muscles to carry out the tasks. Then outputs, which are the movements of the related muscles, are executed. The basal ganglia and cerebellum will also form and fine-tune set of motor neurons to perform these habitual or routine tasks even faster from time to time.
Have you ever wondered why you feel happy, sad, or angry? The external inputs that we see, hear, smell, taste, touch, and internal inputs such as thoughts, memories, or imagination can trigger our brain to create emotional responses. Once the brain detects emotion inputs, the thalamus in the brain, which is a relay station, will send this information to amygdala. If the inputs are emotionally significant, amygdala will command motor cortex to create movements accordingly. For example, if your eyes see a smiling face, amygdala will perceive that as a pleasure, and it will send signal to motor cortex to create movements of your facial muscles to smile back. Or your ears hear the dog barking. Amygdala can perceive that as a threat, so it will command your leg muscles to run.
Fourth, positive inputs. When there's an input through eyes, nose, mouth, or internal happy thoughts, thalamus, the brain's relay center, will send the signal to amygdala to process emotional significance, whether it is a threat or a pleasure, and to hippocampus, which is like the memory drawer of our brain, to compare with the past experiences. For positive inputs, amygdala will label it as positive. Then thalamus will send signal to activate ventral tegmental area, VTA, to release dopamine. Dopamine excites Na-Te-Ei in the ventral striatum. Then ANAC activates basal ganglia circuits. Basal ganglia then activate motor cortex. Then the motor cortex executes goal-directed movements. The dopamine release creates motivation and pleasure to do the actions. If the experience is highly rewarding, the hippocampus and prefrontal cortex strengthen positive neural pathways, and this positive memory is kept in hippocampus. This will be used to interpret future inputs. If there are a lot of positive memories in the hippocampus, aka the memory drawer, it's going to be easier for the brain to interpret future inputs in optimistic ways. Therefore, it is useful to reframe the negative memories in the hippocampus to see them in the positive angle, in order for us to interpret future situations
in the positive light. We will go through that in a future video. From our first example from video 1, when Tony sees a dog and hears the dog barking, Tony's thalamus sends the image to the amygdala, which quickly signals pleasure. The thalamus also sends the image to the hippocampus to compare with Tony's past experiences. In the memory drawers, Tony had very lovely experiences with dogs barking, as they always end up playing together. Amygdala directs the signal from this input through positive pathway to create the outputs accordingly. Also, Tony's hippocampus sends positive memories to prefrontal cortex, which is Tony's brain decision-making center. The outputs for Tony is happiness and excitement to play with the dog.
Fifth, negative inputs. Let's use Annie's case as an example. Annie sees the dog and hears it barking. Her thalamus, which is the brain relay station, sends the signal to amygdala and hippocampus. Amygdala labels it as danger. Hippocampus compares inputs with past experiences and evaluates whether the noise and the image are things she has encountered before. If it's unknown or similar to a past threat, that she got bitten by a dog, which barked, the hippocampus intensifies the fear response by amygdala. Her hypothalamus triggers an increase in heart rate. Her prefrontal cortex decides for her to run and sends signals to her muscles to run. Meanwhile, her hippocampus recalls that dogs barking could also harmless, and her prefrontal cortex helps her decide whether to stop running and stay calm. Now congratulations to you and me that we've gone through all the 5 brain pathways to interpret different types of inputs we can see from our Tony, and any example that, from the exact same situation, 2 different people can interpret the situation very differently. Tony interprets the situation as positive due to positive similar past experiences related to dogs that are barking, stored in his hippocampus or the brain memory drawer, whereas Annie interprets the exact same situation as negative due to negative similar past experiences related to dogs that are barking, stored in her hippocampus or the brain memory drawer. We don't actually know if this specific dog will bite them or play with them in this situation. However, we could see that Tony will be more calm in dealing with the situation than Annie. Therefore, in the future videos, we will reframe as many memories as possible from negative to positive to prepare for positive interpretations of future events.
Thank you very much for watching. Please do like, share, and subscribe to our channel.